This is a video on Venn diagrams and how to use them to determine how many are in different sets. So let's just talk about this Venn diagram. So we have this circle here representing set A, this circle here representing set B. There's no other part of the diagram, so that would be considered everything that we know. So this is, again, just the number in each of these regions here. So this 9 would be represented by this kind of crescent moon area. This 11 would be this crescent. And this kind of lune, L-U-N-E shape, is a 4. So let's just talk about how many are in set A. And again, set A is this circle, which would be all of these 11 and those 4. So we're looking at, there are 15 in set A. And set B, we're looking at all of those. So it'd be 9 and 4. 9 and 4 is 13. Let's talk about the union of A and B. So A union B would be anything in A and anything in B. So you'd think, oh, that should be 28, right? Because there's 15 in A and there's 13 in B, but there are these 4 that are overlapping. So when I add the 15 and I add the 13, I'm actually adding that 4 twice. So we're actually going to take, if we're looking at the union, if we're looking for the number in A union B, we're going to take the number in A, we're going to add the number in B, and then we're going to subtract the number in A intersect B. So the number in A was 15, the number in B was 13, and the number in the intersection, the overlap piece here, is 4. So we have 15 and 13 is 28 minus 4 is 24. So how many total would literally, the other way we could look at it is if we just added the 11, the 4, and the 9. 24. Here's a slightly more complicated scenario where we have 3 sets. The number in A. Here's A. I'm going to add up all of those pieces together. So 5 plus 3 plus 2 plus 1 plus 7. 5 plus 3 plus 2 is 10 plus 7 is 17. The number in, I guess I'll go B next. 2, 3, 2, and 4 are all within the circle B. And we have 5 and 6, which would be 11. And then the number in C, 8, 7, 2, and 4. 15 and 6 is 21. And then we have some overlaps to take care of, quite a few. We have, excuse me, A intersect B, we have A intersect C, and we have B intersect C. So let's look at A intersect B. A intersect, here's A, here's B. The overlap would be this region here. And again, we're looking at just the number in each of these, and that would be 5. A intersect C would be this region here, 7 and 2, which would be 9. And then B intersect C would be this region here, and there are 6 things in there. Now, these all just represent a number of things, not the number 8, but 8 actual items in there. We could do a bunch of other things. Let's look at A intersect B intersect C, which is the overlap of A, B, and C, which is just this middle piece here, and there are 2 in that set. How many are in A union B? How many are in A union C? How many are in B union C, and then lastly we'll do A union B union C. So A union B, anything in A, anything in B. So basically, I'm going to add up all of the numbers except 8. So 5, 7 is 12, 14, 18, 21, 23. A union C, everything not in B, all those numbers. So it's everything but 2. So 5, oops, I'm going to use my laser. 5, 10, 17, 21, 29. And then everything B union C is everything that's not in A. So everything but the 5. Here's 15, and 6 is 21, and 5 is 27. And lastly, A union B union C, if I just add up all of the numbers, that's 10, 17, 19, 23, looks like 31 altogether. So that's how we can use a Venn diagram to count the numbers in each set. And eventually what we're going to be looking for are probabilities of these things. But for now, we're just counting how many are in each of these sets.